In this video, we're going to see how well you can apply some of the things you've learned in the last two videos. And we're going to do that by tracing through three very short code examples. Before we go into the first example, let me suggest some ground rules. For the next three slides, get yourself a piece of paper and try to figure out the output of each of the three examples. But try to do it all in your head, and once you think you have the answer, write it down. Then, after we trace through each example step by step, you can go back and check if your answer was correct. Okay, with that, let's get started. In this code, we declare two int variables, x and y. X is initialized to 23, and y is initialized to 47. Then x is assigned to y, and 86 is assigned to x. I'll give you 5 seconds to pause the video, figure out what is printed for x and y at the end of this code, and write it down on your paper. 5 seconds starting now. Okay, good. Now, like I said, we're going to revisit each of these problems and trace through the code step by step, so I'm not going to reveal the answer yet. Now let's look at the second problem. Our second problem involves the rectangle class we talked about last week. The first two lines declare and initialize two rectangle variables. The rectangle box 1 has its xy coordinate at 0, 0, has a width of 100 and a height of 50. The rectangle box 2 has its xy coordinate at 20, 20, has a width of 80 and a height of 40. Then box 1 is assigned to box 2. And then the transpose method is called on box 1 with argument 10, 10. Just as a reminder, the transpose method transposes the xy coordinates by adding the first argument to the x coordinate and the second argument to the y coordinate. So if I applied that transpose method with arguments 10, 10 to a rectangle whose xy coordinates were 90, 90, I would end up with a rectangle whose xy coordinates were 100, 100. Also, recall that the toString method for a rectangle prints the word rectangle followed by the values for its x-coordinate, y-coordinate, width, and height. Got it? Okay, now take 5 seconds to pause the video and write the output of this code. Remember, try to do the calculations in your head and just write what you think will be the output. 5 seconds starting from now. Okay, good. Let's move on to our last example. For our last example, we'll work with strings. Two strings are declared, string 1 and string 2. String 1 is initialized to hello with a capital H, and string 2 is initialized to goodbye with a capital G. Then string 1 is assigned to string 2. And the method toLowerCase is called on string 1. Now, I'm not going to explain to you exactly what the method toLowerCase does, but you can probably figure it out by its name. Again, I'll give you 5 seconds to pause the video and write down what you think would be the output of this code. 5 seconds starting from now. Okay, good. Put your answers aside and let's trace through these code examples. We'll start with the integer example. We call this a tracing table. The program states occur before and after each statement. I'm going to treat state 0 as the state of the program just after we've initialized our variables and just before we do the assignment statements. Also, I'm not going to include the print line statements because once you get to state 2, it'll be pretty obvious what's printed. Okay, here we are in state 0. Because x and y are ints, and ints are primitive types, x and y and their integer values reside on the stack. We don't have to worry at all about the heap or objects in this example. So let's take this to the next state. What are the values of x and y in state 1 after we execute that assignment y equals x? This one should be fairly straightforward, but I'll still give you 5 seconds to pause the video in case you need to do that. 5 seconds starting from now. X has the value 23 and y has the value 47. So the assignment x equals y assigns the value of x, which is 23, to y. Therefore, after the assignment y equals x, both x and y have the value 23, like so. Great. Now take 5 seconds, if you like, to pause the video and tell me what state 2 will look like after the assignment x equals 86. 5 seconds starting from now. All right, the answer is that in state 2, x is 86 and y is 23. The assignment is to x, so x's value changes. The int variable y is not involved in the assignment, so y's value remains the same. Is that what you wrote down on your paper originally? If so, congratulations. You can successfully reason about integer code. Now let's move on to something a little more sophisticated. Now we've got an example using reference types. Rectangles are mutable objects, which means their state can be modified. Variables box1 and box2 are reference variables, so their values on the stack are addresses that refer to specific rectangles on the heap. In this case, box 1 refers to the rectangle with coordinates 0, 0 and dimensions 100, 50. Box 2 refers to the rectangle with coordinates 20, 20 and dimensions 80, 40. Instead of asking you to describe the entire state in state 2, I'm going to ask a simpler question, or two simpler questions. Consider the assignment box 2 equals box 1. The first question is, will it affect the stack? In other words, will it change those addresses in the yellow boxes? And the second question is, will the assignment affect the heap? In other words, will it change any part of those rectangle objects in the pink boxes? I'll give you 5 seconds to pause the video and answer these two questions. 5 seconds starting now. The answer is that when you're making an assignment between reference types, the assignment affects only the reference, never the object. Therefore, the result of assigning box 1 to box 2 is that box 2 gets box 1's reference value, and nothing on the heap has changed. As a result, both box 1 and box 2 reference the exact same rectangle on the heap, the rectangle with coordinates 0, 0 and dimensions 150. Another way of saying that is that box 1 and box 2 are aliases for that rectangle. Some of you may be wondering what happens to the other rectangle at address 53. Well, that rectangle was created when we initialized box 2, and now box 2 is pointing to a different rectangle. Since there are no other variables referencing that rectangle, there is no longer any way to access it. So it's just sitting around and taking up space on the heap. In that case, it's officially considered garbage. And the Java language has an automatic garbage collector that periodically analyzes the objects on the heap. And if it determines that an object is no longer accessible to a programmer, it'll destroy the object and reclaim that memory space. Let's move on to our next state transition. How does the state change as a result of the call to transpose from box 1? Let's ask the question similar to how we asked it about the first transition. Does the stack change? Does the heap change? Or both? 5 seconds to pause the video and think about it, starting from now. The answer is that method calls modify the heap. They do not modify reference values. Given that, it should be obvious how the heap has changed. Box 1 is the calling object, and its reference is at 47. So the rectangle at 47 is the one that is modified. It's transposed 10 units to the right along the x-axis and 10 units down along the y-axis. So it ends up with coordinates 10, 10. And now that we have our final state, you should go back and check the answer you wrote for this problem. Both box 1 and box 2 should print out the rectangle 10, 10, 150. For our final example, we're working with strings. Strings are reference types, but unlike rectangles, strings are immutable, meaning their object values, once set, will never change. We start with string 1 referencing the string hello, and string 2 referencing the string goodbye. In the rectangle example, we said that assignment changes reference values, not object values. So the effect of the assignment string 2 equals string 1 should be fairly obvious here. But I'll give you 5 seconds to pause the video if you really want to, starting from now. Okay. String 2 gets the reference value at 41. So both variables are now referencing the string object hello with a capital H. The next transition is a bit tricky. We have the method call toLowerCase with string 1 as the calling object. Now some of you may feel there's something not quite right about this, and you would be right. But before I ask you to figure out what state 2 looks like, let me just assure you that this statement, exactly as it's written, and in this context, is perfectly valid Java code. It will not give you a compile time error, and it will not give you a runtime error. So with that information, let me ask you this question first. Do any of the reference values change after this statement? 5 seconds starting from now. The answer is no. Method calls do not change reference values. That means that any potential change must be on the heap. Therefore, how does the heap change from state 1 to state 2? I'll give you 5 seconds to pause the video, starting from now. Okay, this is a bit of a trick question, and the best answer I can give you is this. As a result of this call, a new string object is created on the heap with a value of hello in all lowercase letters. However, because there is no variable to assign this object to, it is ignored and garbage collected. Now, in practice, the Java compiler would probably not even create the new object, but I put it in here to illustrate the behavior of toLowerCase. Like all string methods, the method toLowerCase does not modify any existing string objects. That's because string objects are immutable and once created cannot be modified. Instead, the toLowerCase method is a pure function that returns a new string object. When I say pure function, I mean that it returns a value and it does not have any side effects. Calling a pure function without assigning the result to a variable will have no effect on the behavior of the program, except that it may needlessly take up some time. Therefore, you should never write code that looks like this. You should never call a pure function without assigning the result to some variable. Okay, so let's modify this code so that it makes sense. Instead of calling toLowerCase without assigning the result to a variable, let's assign the result to string 2, like this. Then, when we transition from state 1 to state 2, we get, well, what do we get? 5 seconds to pause the video and figure it out, starting from now. The answer is, we get something like this. A new object hello with all lowercase letters is created, and it's assigned to string 2. Remember that assignment changes the reference value, so string 2 gets the address of the newly created string object. String 1 still points to the string hello with a capital H. Nothing points to the string goodbye, so it'll eventually be garbage collected. And that's it for this week's lecture on memory and mutability. I'll see you in next week's module when we'll discuss abstraction and talk a little bit about some basic data types.